All right, cool. So we're gonna do a sort of a deep dive, a look through into HomeKit, but also reverse engineering. Why are these two things similar at all? I don't know how they have to do anything with each other. Well, this is really a story of my mind and how it works and how people tell me all the time, Zach, you've given me far more information than I could have possibly asked for or known what to ask for. Or man, you're really taking a long time on micro optimizing, enumerating through this thing. Why can't you do it faster? Or whatever, right? This is just sort of how I am, and I've learned to embrace it, to use it to actually speed up my workflow and to do things that other people in their day to day think aren't really necessarily possible. So what does this come down to? What is this obsession that I talk about? It's not just about observing the realities of a system when it comes to something like iOS or implementing a feature using UIKit. It's not just good enough for me to be like, well, we fixed this problem because we toggle that checkbox and everything works now, and right, we can go all home and happy. No, it bothers me until I know why that is. Right? So almost every day, if a question comes up, if I'm thinking through a hard problem, if I'm looking for examples, I have a disassembler open next to me almost all the time, or I'm willing to fire open a debugger and figure out, well, okay, what actually is the thing that's happening here, not just observing the emergent behaviors of the system. Because as you get familiar with the design patterns of the frameworks and authors that you're working with, or the systems that you're trying to affect change in, you start to get more familiar with the trade-offs that they're making, the sort of edge cases that you might not have been thinking about before. For instance, before we started recording, right, we were talking about the edge cases involved in designing something for thread safety, and how, even perfectly intelligent people go and design something that is flawed and then put that into the world, and they're like, shoot, I have to go back and address that or remove it, and how those kinds of decisions or avoiding those kinds of mistakes are what get you to a certain place with working with an API or something that you're frustrated with about it. And really, what it comes down to is this is how I leveled up as a programmer from being a junior dev, following through the Big Nerd Ranch guide on iOS dev into what some people sometimes refer to as a senior dev. It's just that is the path that I took. It's not a path that necessarily you have to take, but it is something that I use, a practice that I use to level up myself and the people around me. All right, so how does this relate to this whole HomeKit thing? What are we actually here for? Well, there was this cool thing, this announcement, really at the beginning of this year, about just over a month ago at CES, and it actually one of the few surprises of what I think is a stunningly boring sort of, oh, look at what we can do kind of event. There was the surprise announcement of, you get all the year's TVs, right? Your $8,000 rollable TV or whatever that was announced this year, but also came the surprise announcement of AirPlay 2 integration and HomeKit with a whole host of non-Apple TVs coming out this year. And we can wax philosophic about what that means for Apple or their content ecosystem or whatever, but I was immediately excited about just the nuts and bolts of it, of this image that you can see here on the screen of just like controlling from my phone, which I always have glued to my hip, and not having to hunt for the remote. Or being able to do all of the automation things, which we'll talk about in a second, that you can do with the home, like make sure the TV is off when I go to bed, that kind of thing. About connecting together these pieces of an ecosystem that were just fundamentally against each other before. And so this immediately got me going of like, I have to know more. I have to dive deep in onto this kind of thing. And that was a sucky feeling because I already have a TV. I don't need a new TV right now, although after seeing some of the $8,000 rollable one, I wanted one, right? But no, I actually already have a TV, and it's a really nice TV. In fact, like it was the wire cutter pick at the time. It actually still is the top of the list, right? So I don't want to replace my TV. I don't want to like upheave all of the stuff in my life just to get this one feature that I wanted out of my electronics. So, what are we left with? What can we do about this? We could file an angry petition, say, I'll never buy from you again, LG, unless you update my existing TV with support for this other platform that you had no idea about a couple of years ago. I wish that was a joke. That's actually one of the most common responses to, I think, Vizio's announcement of their HomeKit support is people upset that they can't get a software update, which is actually a fair sort of criticism. But anyway, what it comes down to, though, if we're talking about, being a technical person and being willing to dive deep into some of this stuff, or maybe if you're not overly technical but you're really good at following tutorials, almost always in these cases with these smart or pseudo-smart devices is they have programming interfaces, and they may be obscure, they may be Baroque in the old art sense, right? They may be really hard to get into, but these things are programmable. And the system, HomeKit, is programmable as well. So let's dive into what actually is this thing that we talk about when we say HomeKit, right? We think of this home app that you can see here on the TV, and that's just going to be stuck up here until we get to the latter part of the talk, right? We think of all these shiny, pretty iOS ideas of a modern automated home, dealing with Siri and all that kind of things. But HomeKit is not just that, is not just the Siri interface and the Home app. HomeKit is a platform for building applications and hardware that talk to each other in a more or less agnostic way. So it is a networking platform that describes a superset, a layer on top of HTTP for accomplishing these common Internet of Things, sort of home automation-oriented tasks. We'll talk more about what those kinds of things mean in a second. But what sets this system apart from basically everything else that's going on in the Internet of Things industry is that HomeKit starts and ends inside your home. It uses the devices that you have in your house and the networking that you have in your house, and by default, it doesn't leave the house. Even without those defaults, once you enable remote access, it still doesn't go out to the public internet. It's traveling over service discovery and permission discovery using your iCloud account. So beyond that, beyond the nuts and bolts of it, HomeKit is centered around accessing these different concepts of home automation that compose with each other in a convenient way. So this is abstracting over, I want to turn a light bulb on and off, or I want an outlet to turn on and off, or I want this thing to turn this certain color, right? It is a common platform for all of these automation type triggers. And of course, we already mentioned Siri and the Home app. And those are primary, features of this system, is that they define a common set of functionality and utilities to allow a more limited system like Siri to accomplish that human interaction, that voice interaction really efficiently and hopefully, less buggily than normal. But it's more than just, that on the surface convenience of having home automation, or a connected home, is that this is all about security. It takes care of the pairing process in its protocol. It describes permissions and how other users that aren't you can access your home, or how members of your family can access your home. This is, again, without exposing it to the public internet, without something that hackers can get into or you can accidentally leave someone on the permissions roll for. And like I already alluded to, it solves the remote access problem of wanting to check my home doorbell camera from wherever I am in the world, or make sure the garage door is closed after I drive 2 states away, without exposing it over the public internet, but just direct peer-to-peer from my phone over several thousands of miles of layers of networking systems to access these systems directly. It also handles that concept of pairing and discovery that's usually so hard, especially if you're dealing with something you're physically drilling into your house or installing up under a thing, having to press and hold the Bluetooth pair button to be able to get it, oh wait, no, I need to get it closer, so my phone can pair with it. No, it answers for the pairing and discovery process, just sort of as part of the fundamental functionality of the system. So that's all cool and all, right? We were talking about, diving deep into reverse engineering. Okay, cool. How do I get in to this HomeKit thing? I know Apple is super duper locked down in all these sorts of ways, so maybe I have to make an app that goes through them that they check exhaustively, right, to make sure that I'm doing the things that they want me to do with Internet of Things. Or maybe I have to go through that cable production program, right? I have to get a big corporate license or something. Or maybe they just don't allow anyone to it at all. It's only for friends of Apple, and you actually have to hire a friend to break into Apple and get you all this information out. Actually, it's not necessarily any of those things. Now, there is the corporate access to HomeKit that you can get if you are trying to publish a product on the market. But if you're just a home brewer, right, a single engineer, a maker, a kid, any of these people can, for free, get access to the HomeKit accessory protocol. The only issue that using this protocol provides is, well, technically you can't sell what you're doing as a business, right? As we're making these Kickstarter widgets for home stuff, and we're doing it using the independent indie thing. You would still have to become an MFI license for that, but you can freely get access just by going to developer.apple.com and saying, I promise I'm not actually Facebook wearing a trench coat. Give me access to this document. And it's actually a very exhaustive document describing all of those protocol features that I just mentioned too. Things like the pairing process and stuff like that. But here, let me actually pull it up real quick. It's here somewhere. Yeah, there we go. Yeah, here you have this HomeKit accessory protocol, right? And it is a dense document. There's a lot of stuff in here, but it is all describing how to both you, the developer using the HomeKit accessory protocol, and the end user, most importantly, the end user, right, as with all things Apple, most importantly, the end user get the benefits of a really cheap, cruddy widget that you buy at Target that actually exposes your garage door opener over public Wi-Fi, right? To take the convenience of something that doesn't have any security or any sort of resilience to error, and to actually make it, mask over it with this sort of relatively simple system. So what is the HomeKit accessory protocol? And it is actually called HAP for short. I wasn't just making that up. It is a specification for this protocol. What HTTP methods am I calling to get a list of this thing or that thing? It is a definition of the data structures that are used to implement these systems. And these data structures are actually really interesting because they're not quite what you think they would be, right? You don't just say, I have a TV. There are actually several moving parts that go into a TV to make it more flexible for the future and for building out the kind of product that you want. The other thing, and the really, really important thing that HAP defines is the common definitions for things that Apple supports, right? Things that come with the support for things that come with the OS, right? Lights turning on and off. Things that you would think to use in a pretty UI in the Home app. But what's important before we continue, and what I'll return back to later, is that the HomeKit system, the HomeKit accessory protocol, is not actually limited to any of those device definitions at all. It is simply describing them to you as a bit of an informal agreement between you and Apple. And in fact, you can compose together many of these different concepts that we're about to talk about and build them into something unique, something just for you. And the HomeKit system will try and do its best to expose that functionality to the user. And if you're doing this more in the real world, that actually means that you can do things like build an app that talks to a hardware that you build in a very resilient and secure manner. Two things that you know that Apple doesn't need to know about. For instance, if we're talking about products, I think one of y'all mentioned like a thermostat. Those thermostats, one of the common ones like the Elgato, no, sorry. What's the one? Ecobee, thank you. The Ecobee system declares graphs, energy usage graphs, historical data, all using HomeKit that their app then ingests. They don't have to design a separate web service, a separate data store for all of this information. It's in fact right there on the device and goes directly to your other device that you're looking at this information with. It all travels over HomeKit and gets all of those benefits of HomeKit overall, and it still isn't necessarily something that appears in the Home app. All right, so what is this hierarchy? What are these data models that I'm talking about in HomeKit? There's this sort of hierarchy, this pattern of what devices go into HomeKit, how you declare what something does in a way that you may not actually be that expecting, that familiar with. So you have the products yourselves, the product categories, things that you would probably buy at a store or package up into a box. These are called, in HomeKit parlance, accessories. So accessories are the level on which, for instance, I may add something to HomeKit. As you can see on this screen here, there's a big chunky button that says Add Accessory, right? You're adding something to your home. I can tap it right here, although we have nothing that's trying to pair right now, right? The accessory is the thing that you'll slap a HomeKit sticker on and say, my PIN number is this, right? And then, of course, because it's something we can do now with machine learning, there's a nice little QR code scanner here, so you can just add it, all just by waving your device in the direction of something you just bought at the store. So really nice and convenient. But now, how does HomeKit interact with these accessories? Because this is pretty advanced, right? This whole list of things. Like this describes a whole lot of what you might want to buy at a store to automate in your house. But these very concrete definitions of products are limiting in the end, right? What if I had a garage door that I wanted to lock? What if I had a light bulb that had a temperature sensor in it, right? What if I had a very common one, a TV that has speakers, right? These device categories don't necessarily correspond with, this nice pretty marketing list from Apple.com doesn't really correspond with how we want to engineer these devices or how we want to build them. So that leads to the major thing, major other tree of data inside of HomeKit, which is the service. The service is one of these aspects of a device, a concrete piece of functionality that the product you bought at a store supports. So the way to think of this is most of the time, not all the time, but most of the time, it's probably going to show up as a tile in the Home app. These services are things like lights, fans, that allow you to compose, or rather decompose, the physical features of your hardware into things that the user can control. So let's think back to this list for a second. What can I do by composing services? The one that we saw on this other screen was a light and a fan. That's a ceiling fan, right? A light and a fan combined. A thermostat and a blower, like a fan blower, that's a window AC unit. Maybe I want to have this horrible amalgam Simpsons device that's just like covered in buttons and sensors. Like it's just a ball that I throw in the middle of my house and it just sort of soaks up data. That can be any number of sensors, censored pieces of data, just shoved together in HomeKit. One device that already exists on the market that is such a thing is a combination motion sensor and temperature sensor, which are super cheap to build and to make, to sell. They probably come with tiny little watch batteries in them that last like 1,000 years because Bluetooth LE is like pretty advanced. And these things can communicate to HomeKit and then allow you, the user, to consume those different services, right? So you can say, well, I want the room to be warm when someone's in it, of course, but I also want to warm it if it gets below 30 degrees in there. Something along those lines. But, the actual properties, the things we may want to control about those services are not just reduced to things like light or fan. What if it's a light that you want to control the color of, right? What if it's a fan you want to turn on or off the oscillation on? That's where the final moving part of HomeKit comes into place, which is the characteristic. If you're writing basically Swift code, right, or a class, right, these would be the properties on that class. And they support, just like if you're writing code, a lot of the things that you would expect them to, right? Read or write, broadcasts notifications, read only, that kind of thing. So all of the things that you can change about a device or information that the device can display to you, right? That's just like a one-liner, right? That's basically as broken down of a piece of information as it can get. These pieces of information are broken down into the smallest parts because they're a limited set of types, right? And this is very much on purpose, right? Is it on or off? That's a Boolean. What mode or what input is the TV on? Which we'll see in a second, right? That's an integer. What percent intensity is the light at, right? Percent, floating point. If it's just some arbitrary string, right? Like the user wants to assign a name to the light that's in a certain person's room. And finally, there is an escape hatch sort of data type as well that allows HomeKit to compose much more advanced functionality called TLV8, which is just an extremely basic, the world's simplest version of protobuf, really, is something that you and whatever the device agree on to say, all right, I'm going to send you a sequence of values, right? And value number one is the, let's say we're talking about like a doorbell camera, right? Value number one is the width of the image feed. Value number two is the height of the image feed. So they don't have to say separate characteristics for those things that are actually just one thing, which is what camera feeds I support, right? And so you take the, I'll get to you, I promise. So, you have this table of like what this characteristic is about, and then the length of the encodings, and you just splat it in binary right after that. So it's really efficient to parse. Step?
Okay, so that's, I think you implied this, they've all got to be the same type. It's going to be only ints or only strings or whatever for all the values?
In a data payload? No, they can be, that's the length part of it. They can be mixed binary data, but you say I'm about to have you'll document it. You say value number one is an, yeah, exactly, the binary length of each value. So you can encode a string in just an arbitrarily long sequence, right? And so this can be used to shuttle forth lots of data, like the graphs we were just talking about. Okay, so we have this idea, right, of what it means to have a product, what it means to have the product have features, what it means for those features to have individual properties. But that's not really useful to us unless we sort of agree on what those can mean. iOS, through the use of the HAP specification, knows a lot of hard-to-find characteristics, knows a lot of hard-to-find services. Services are usually just ways for it to group characteristics together or give it a pretty icon. But it knows then mostly about how you assemble the characteristics, and it can make good guesses about what kind of UI it can show to the user. But again, even if it's not making a good guess, you can build an app that interfaces with it however you want. But for instance, almost certainly the most common one, if you have a switch, an outlet, a refrigerator, a ceiling fan, or whatever you can think of, you're going to have what? An on kind of specification, right? A binary state that describes physically, really, whether power is going to a circuit. Yes?
Would you have one of these even for something like a refrigerator where you don't want to turn it off?
No. Well, what if the refrigerator could tell you whether it was off? You know, that's a matter of whether it has electricity going to it or not. But yeah, if it's something that can change, maybe through user input, maybe through external input, through input from the universe, is when you would want to express it as a specification. But yes, that's a good point. Unless you mean to turn it off, maybe a refrigerator wouldn't be such a good idea. But
Like a battery backup.
A battery backup, yeah.
Hey, I've lost power.
That's right. And there may be another characteristic that more concretely defines that concept so it can display you an alert about battery level in the home app or that kind of thing, right? But the composition of these things matter. When iOS notices that you have an on characteristic attached to basically anything, Home app can more or less just know it gives that a switch UI. Depending on how you want to format your services, this can basically, for like a stunningly high number of scenarios, give you Siri support for free, right? Ahoy telephone, turn off this light. Turn on the refrigerator. Even before we have the TV support that I was talking about for a second, people homebrewed TVs just as switches, right? Because the system can give good UI for a lot of these things that it's defining values for. And again, even if you don't want to use one of these defined characteristics, I don't know if you can see this because of the TV here, but like a characteristic is a UUID and it's type. We can move this ever so slightly. Right? If you want to come up with your own UUID and say this UUID means, I don't know, the amount of noise my noisemaker makes, right? You can define that characteristic if you want. But these public characteristics are, right, the bread and butter of how we build out these systems. So when it comes to, I'm sorry for the puns, y'all. When it comes to, right, actually using an implementation of HAP, you'll find one off the shelf. Most popular one is one written in Node because it actually deals with, Node.js, JavaScript, or TypeScript, or whatever you want that compiles down to JavaScript. Because it deals with sequencing together asynchronous stuff surprisingly well. And that's what I've been working with and what I'm going to show you here in a second. But there are also implementations out there for really whatever. And Swift is a really good one because of course, the brand synergy. But there are also concrete reasons you might choose to have it be in a specific language, right? If it's really good on running on low-power hardware, that kind of thing. All right, so we are going to do a live coding exercise, which is insane, but here we are. Okay, so I'm going to, not that one yet, but let's see, open a second file. There we go. Okay, cool. So I already have like all my dependencies installed and that kind of noise, but we're just going to pop open this. So I don't know how much everyone here is comfortable with JavaScript. Well, comfortable is maybe not the term I should use, but can see the syntax or read it. So I'm just going to paste a bit here at the top. So this is just pulling in dependencies, right? It's just basically giving us names for a lot of these functionality of this framework we're going to be using. You'll notice that this implementation of HAP, as I imagine most of them, define high-level data types, right, for that HAP hierarchy of objects we just talked about. So I'll come back over here. Now this is just some gobbledygook associated with the, yes, step?
Can you define your own accessory that's maybe made of accessories? Can you have a TV and speakers accessory?
Yeah. So the system's going to identify a lot of those paired relationships, but you can tie together two services of two services of an accessory as being intrinsically linked in some way, and that might have an effect on the UI as well. That goes back to like the things like the thermostat, the window AC unit example I used a couple of minutes ago, right? Because those are intrinsically linked in a way. That's right. If one is on, the other may not necessarily be on unless I want to change some other another characteristic. Okay.
So just to make something clear, that I've got like a little, you plug it into the outlet and you can plug a lamp or whatever into it. And it's also got a little night light built into it. So is the whole device the accessory and the night light and the plug both services then? How do you get that?
Yes, exactly. So individual, basically physical features of the device, a function that it performs are going to be a service. And then the whole thing together is an accessory. So the accessory is the thing you add or remove from HomeKit itself.
It requires one QR code.
That's right. One QR code, one Wi-Fi or Bluetooth connection, right? If that fails, all the services related to it fail, right? It's so this kind of top-down hierarchy.
And the accessories aren't limited to that list you showed.
That's right. Yeah, because an accessory is really is at the end of the day just a name. It is a name and a combination of services. And the accessory being a well-defined thing in the specification are just conveniences for Apple to be able to put a little cute fan icon next to it. But if you don't provide enough information for it to do, it'll make good guesses for all of them, right? You want to bind the name of it. You can create a custom anything really in this realm, and then give it for instance, custom characteristic, a read-only characteristic that's like name, right? I am, Bob's Wonder Device. It'll show up in the OS as Bob's Wonder Device, right? And Apple doesn't need to support that kind of special combination thing. Cool. So we're just at the pulling in data types part. Does anyone have any questions before it's actually going to get?
Just completely unrelated.
Yes. Well, it does matter because we'll be killing and rerunning the server, but it does matter, right? These things have persistent definitions. HomeKit has to know how to be able to talk to an accessory that it previously registered.
Right, but node persist is just one way to do persistence.
Is just a way to do persistence in this setup, right? If you're building an actual physical real device, right, it may have some non-volatile RAM of its own. Okay, so now let's actually get to some meaty stuff. So why this storage thing matters, let me expand this window. Why this storage system matters is because we're going to generate some UUIDs that actually have some concrete meaning to us. I could have just hard-coded a UUID that I just made up myself here. Here it's using it to seed the value actually with some binary data, right? But basically the idea is I'm creating an accessory, but I want it to be persistently identified by some kind of UUID. And that'll live across instant invocations of this server. So next, after that, we're going to create this accessory that we're going to call a button. It doesn't actually behave as a button, but it's going to implement a switch service. But for our purposes, and what we're going to see in the Home app, it's a button. And this next line is a surprise that we'll find out later. Okay. So we're going to take this one line at a time. So we're going to take this accessory that we just instantiated, and we're going to add a service to it. This framework comes with all of the service and characteristic definitions outlined by the HAP document. And again, you can create your own at any time. But using the template ones that it provides to help you solve for what is the UUID of this? What are the properties it expects? All that information. Services are interesting because, right, they have a number of required characteristics if they're one of Apple's predefined ones, and optional characteristics. A light bulb service, what if we had a light bulb, what's the one thing we can agree on that a light bulb is going to support? On and off. How do we also include light bulbs that have color? Well, we'll have an optional characteristic expressing the color of that. What if some other manufacturer says, we don't want color through RGB, we want color temperature? That's yet another characteristic, right? And these things can be mutually exclusive. So we're just going to add a service which templates out all of this information for us. This framework will even help us fall back and do some of the nuts and bolts of like every service requires a service information set of characteristics, things like name, serial number, that kind of stuff, and it's helping take care of that. Now, we're going to fetch one of those template characteristics that it defines, right? That simple on-off that almost every accessory can agree on. And again, because this is sort of JavaScript and everything's sort of wild and crazy, we haven't explicitly instantiated this characteristic, but it's just helping us go through it anyway. So we can write some pretty nice and pretty syntax here without explicitly setting up all of these different things.
So the service, seems like a switch service would come with a characteristic.
No, yeah, because it's a required characteristic, it's going to create one of those objects for that behind the scenes for us,
Okay.
right? But as it is written right here, this characteristic doesn't do anything. It doesn't respond to anything. HomeKit can communicate with this characteristic and say, on, off, I'm turning you on, I'm turning you off, I'm turning you off, but nothing's going to happen, right? We need to bind to it. We need to perform some action when the value changes. So again, because of this framework encoding the HomeKit specification, yeah, it already knows all of those common things, right? It knows that the on characteristic is going to have Boolean storage behind the scenes. And again, because of JavaScript, it's going to coerce everything to a Boolean instead. But so we need to do something when this value changes, right? If we're creating this button that I'm outlining here, then we want to do something when it turns on. So very common in these HomeKit plugins and in really JavaScript overall is the use of the event pattern, the emitter, right? So here we're going to add a function to execute on the setting of the value. This is interesting, or it's an interesting thing that this framework provides for you because I don't have to, by default, give it anything to get, right? It'll maintain that state, whatever the current value is, on its own, automatically. This can be helpful if you're trying to bridge something in from the outside world that you may not necessarily even have a getter for. If you, this is actually a homebrew project of mine in the past, want to wire up some buttons to fire like IR actions, like I want to control a box fan from across the room. You can have a piece of hardware that emits those IR signals, and you can have a setter emit those signals. But by default, if it's a read-write value, HomeKit needs something to pull out from, right? But I have no possible way of defining what the current value for that is unless I set up a machine learning robot to know, what the current on state of my decades-old box fan is, right? That kind of thing. So anyway, so we're binding to just the setter. And we're going to say, once the switch comes on, right, we want to do something. Boy, is the indentation here great. And I honestly don't know about the triple equals, so please don't ask me. All I know is it needs to be true.
That means really true.
It's super true.
JavaScript,
As opposed to just might be true.
Yeah, we don't even ask anymore.
No.
So
Yes.
so if we're turning it off, we don't need to do anything. We can go ahead and call back and tell HomeKit, hey, the set succeeded, off did nothing, we're good to go. But if it's true, then we're going to do this other neat thing where we turn on and need to re-indent the code manually again. I love doing that. We're going to use that player object I instantiated before to play a sound right here on my Mac. And so only when that sound finishes playing will we inform HomeKit, yeah, the on thing that you asked for, that's finished now. So we've now created an accessory, given that accessory a service, given that service a characteristic. That characteristic will respond to changes that come in from HomeKit. Then our last step here is quite simply to publish it. This framework acts as a server. So we're just going to give it a pin code, right, and a port to run on because it's acting as a server. So what I can do now, if I didn't screw up any of my typing, is run it. It's blank, so that's probably a good thing. Mikey.
Is there any kind of guidance or otherwise for picking a port number, for picking a pin code?
Port can be basically anything because
323 on the pin code?
Yes, it's always 323 on the pin code. Yes, that I do know.
And username looks like a MAC address?
Yeah, it's just going to be the MAC address of your device.
Okay.
Yeah, thank you for both of those. Those are actually good clarifications.
323 address.
I don't 100%. No, it has to be 8 digits.
Okay.
Okay, so if you'll turn your attention to the screen that I've set up here. So I have my iPad, I'm in the Home app, and I'm in this Add Accessory UI. And I don't, I didn't make this product, right? So I don't have a magical QR code to scan, but what I do have is, oh boy, nothing. Cool. Let's see, maybe I did screw up typing. There we go. Okay. Server's running, that's good. Did I get everything in here right? Yeah, this is the fun torture of. There we go. I think it's because I had cached information. There we go. Hey, we see it. Okay. So we have a list of the nearby accessories. I can add this accessory, and we saw over here, I hard-coded a pin code. It's really secure. Please don't look at my luggage. There we go. We set up the accessory. It does some key exchange business, and then it's added. And here I'll just say, I'll call it magic button. And HomeKit will save that locally because I gave it a value. It assigns it a room that I set up in this here big Nerd Ranch house. But what's neat, because the only information we've given it is that it's a switch that turns on or off. The OS is like, okay, well, I can't make a really great assumption with the information you've given it to me, so I'll just give you a picker to say what you think it is. And so here, I'll just say, it's a switch. I'll leave it as a switch. And so now, that was really quick. We've added an accessory. It's done key exchange, code gen, blah, blah, blah. It's all secure. It's all set up here. And now we're going to tap this button.
Eep.
Hey.
Yeah.
So,
Do it again.
yeah. Oh, I will do it again. Off.
Eep.
Hey. Okay. So what that did, and you can see probably some of this screaming by here in the console, is that was the characteristic on. So HomeKit on my iOS device knows, okay, I need to make an HTTP request over here, wait for it to come back, and then it can reflect the UI state as being complete. Imagine all the stuff that it's handling. It is actually not just emitting an HTTP request. It is handling retry and replay. It is making sure that something that you've tried once can't happen twice. We don't want to turn, especially if it's a toggle type, turn on, turn off, we don't want to turn it on and immediately back off, right? So the framework, this HAP implementation, and HomeKit, the protocol, are handling a lot of that for you. So that's just a super simple accessory HomeKit stack. And this is all something that we coded up ourselves, conforming to the specification. Any questions before we move on? Awesome. Because I'm superstitious, I'm going to just destroy the whole world and remove the accessory from my iPad before we move on. It's not something you would do normally. You can add any number of accessories. They all interact with each other. But for the purposes of just keeping the demo sane, let's start with some sane state. All right. So we did a thing. We set up a HomeKit, right? A homebrew HomeKit device of ourselves. But way back a long time ago, probably like hours ago at this point, I talked about TVs and this new thing that HomeKit can do in iOS 12 and with new devices. So we just assembled an accessory out of the public specification that is all documented, right? It says on is this UUID. It is a Boolean. It goes on or off. Very simple, right? HomeKit is still a public protocol, though. Even if I don't know or Apple decides not to tell me what a specific accessory service characteristic stack is, all this information exists in the OS, in the devices that we're using, right? Because they need to support this stuff for someone. And I'm not talking about extremely nitty-gritty reverse engineering, right? Like building all of HomeKit myself from scratch, right? This is, again, a simplified protocol that abstracts over all of these different techniques for communication. Which means to say, if I came up with my own service, accessory, characteristic stack for a TV that answered all the same questions that a real TV, using the secret information that Apple gave to their partners, it's still just as good. It behaves as a real HomeKit TV. But we have to figure out this specification for ourselves. I'm going to show you a little bit more JavaScript. So we take our, on characteristic. And I told you when we were looking at that simple button accessory, right, that the framework is defining all of those for us. I wasn't even doing that much, right? It was taking all the information that it is available in this public document and encoding it here, right? But we can build these out ourselves, right? We create a characteristic template. Again, it's JavaScript, so it's prototype-based programming, so technically any given characteristic is all of the characteristics. It's fine. We're creating the template for an on characteristic given a certain UUID, right? That was right here in the documentation. We set up its properties, which the properties are unique to this implementation, but they describe those sort of meta characteristics, right? Whether it is read, write, what its type is, what its min and max values are. Now, I'm not going to get an example of that tonight, but it's really neat because that metadata informs the UI. Apple's templates here are just guidelines. That's hard to crack with on and off, right? Because your min value is 0, your max value is 1, your step between those values is 1, right? But imagine something like percents, where my device, yes, it expresses 0 to 100%, but we actually step 25% at a time. That's just how our hardware works. It's not actually 0 to 100 then, but hey, that's what marketing wanted. All right, so I can say, okay, my characteristic is a percentage, 0 to 100, that steps 25% at a time. Or if I'm defining a thermostat service, then I'll choose meaningful values based on the physicality of my unit, right? If it goes below 60, it's gonna ice up. If it goes above 80, what the heck are you doing? What kind of heat are you trying to make? You're trying to set your house on fire. So I would set those and say, okay, my min is this, my max is this. My step is, 2, right? And iOS knows to represent those kinds of things in the UI as part of whatever stepper or whatever UI it shows in the home app. Okay, so not that hard to translate given an understanding of what shape a given characteristic takes, right? We can encode it, create values for it in this HAP implementation, right? In this program of ours. And this is where we get to the real meat of it, right? This is, again, all the information that we need exists in the OS. And again, this was a challenge that was too difficult for me to pass up. And this is actually something that I deal with all the time, whether it's dealing with HomeKit garbage or finding out a problem in UIKit or figuring out why performance in this thing isn't behaving the way we expect. This is my scientific process. Is, okay, we need to find out the things that we don't know about this system. First of all, I don't know what implements this system. I don't even know what names they call it. I don't know the semantics of how these things interact with each other. So I start almost always with searching. Really simple, just grepping through a ton of files, right? So what I'll do here, if I'll back out of this again for a second, open my notes, go back to terminal, and we'll say, so we're going to go inside Xcode. Actually, let me go inside the beta, just for good measure. And yes, I do have a text snippet containing this, because this is the path to the root of the iOS simulator. The iOS simulator is interesting because it's all compiled natively for Intel, right? Which means that its disassembly is super easy to read. And they include most of what comes with iOS and a good number of the apps. But all of the frameworks that implement iOS, UIKit, Foundation, and so on. So I'm going to just open this root disk in my text editor, and I'm just going to do a find in files. I actually completely forgot what I would find in files right now.
HomeKit, TV?
Yes. I did this. I concretely did this once. Yeah. TV is not a great one. Television. That might be one. I'm going to turn on case sensitive just to make it a little easier for us. Okay, we're already getting matches, right? That are related to things that we expect this to be in home, right? So home UI servers, that sounds as good of a place as any. That's a good place to start. And just for the sake of time, I'm just going to talk us through this decision tree instead of visiting each one of them. So we have a bunch of the accessibility stuff. So that's going to have clones of all the UI, right, to make it more accessible. So that's probably not going to...
way to discover new words, like pop-up windows.
Yeah, exactly. Exactly, right. So we have strings files right here. Those are going to be binary, but if you read them as strings files, you're going to get localization text, so you can find out the invariance of the system. Because localized text is going to be what? All the error messages, all the instruction text, right? So you find out aspects of the system alone just by reading through text in your language. That was actually the way Face ID initially got uncovered a couple of years ago now, right? It was UI text that didn't properly get stripped because it was fairly unambiguous about what it was asking you to do. Scan your face now, please.
Yeah. Whoops.
Yeah. All right. So then that was very good, Steph. Thank you. So yeah. AirPlay mirroring. Okay, so we're not quite looking. This has a match for the word television in it. AirPlay works on TVs, but that's not quite what we're looking for. So we're gonna keep going. Network. That's way too generic to be, right? It. HomeKit. Now this is interesting, right? This is somewhere that I would choose that I would definitely look in, right? Because HomeKit is the implementation of HomeKit on iOS. That is the client framework for interacting with all these data objects and HAP that I discussed. So, right, so you can query for accessories that the user has added and interact with them yourself. And again, for the sake of time, I'm just going to keep going. But I would definitely look at HomeKit framework. And again, service types .strings, that's going to contain the word television in it, probably for a good reason. I don't know how far we're that scroll bar is quite small. Okay, so television, yeah, but the font's big. Okay, so here's where we start getting into the good meat. You're gonna find should have done that. you're going to find a lot of good stuff in the public frameworks that come with iOS, but any of the really juicy stuff is going to be right in your private frameworks. Home sounds like a really good spot, right? The Home framework is probably going to be pieces of the UI and things that the Home app does, right? So that's another one that I would look at. We're going to keep going. Localizable strings, more strings, more strings. Aha! Here, we don't even have a. It's not even encoded this time. We have a full match for the word television inside the HomeKit daemon. Now, if we just break down what we think that it is, HomeKit daemon is going to do things for HomeKit on behalf of HomeKit in the background of iOS, right? When you don't have the Home app open. So this is probably going to be a pretty important spot for knowing what the state of the world is at any given time, where all of this, like a lot of this real networking type stuff, is going to be implemented. And this happens to, I'm going to spoil it for us, this happens to just be a really fantastic find because, yeah, configuration files. Configuration files are always big winners because they tell you the parameters of the system. So I'm going to open this plain metadata file, and I'm going to spoil it because I already have a copy of it over here. It's actually a plist. The Xcode plist editor is going to be nigh unreadable for us. Let's just double click. Yeah, it's XML. We can sort of read XML. Not that XML. We can search for the word, if I type television. Okay, so television. Characteristics. Okay, so if it's a thing that contains characteristics, I bet it's a service. Right, so we've now sort of, just by double clicking on this file, I've guessed that there is a television service. And this seems to be bore out because it says, here are some optional characteristics, and here are some required characteristics. Sounds like a service to me. I'm actually going to make the font size a tiny bit smaller because I'm losing my mind. 30. Let's just say 30. Cool. Okay. Yes?
That's not
Shut up. Okay. So, all right. So let's pull the string on that thread that we're guessing, even though I know it's right. I already know what this file looks like. So this is the television service, let's say. Here we have a short UUID at the bottom. That's probably going to have something to do with, right, the UUID of the service, what Apple identifies the service to be. And this is the reason that they're truncating them and shortening them is that all of Apple's UUIDs are seeded with the same prefix, right? So if we go back to this the file that we had previously, and I was like, this isn't a really great way to generate UUIDs. Well, they already did it. This is what they did, right? So the first all but the last octet of Apple's HomeKit UUIDs are just hard coded. They're just like, those are ours. Yeah. Okay, so we can combine this together into the rest of the UUID template, and now we have a service, we have a name, we have a UUID. That's great. Okay, so looking at these characteristics are going to be defined elsewhere in the file, but we can, of course, guess to a lot of their meanings just by looking at them right here. Active. Sounds a lot like on or off. Why would we have active instead of on? Sleep modes are a really good one, right? Because if we want to turn the TV on from offness in the first place, well, then it can't be truly off, which is lucky because almost every TV these days is when you turn it off, it's actually in some kind of sleep mode because they run full OSs and they take like ages to boot, that kind of thing. So active instead of on. Configured name, another obvious one, right? Want to give, den TV. Sleep discovery mode, right? Exactly what Steph was saying. Okay, maybe it's not on, maybe it is sort of off, or if like it's shut down most of its hardware so it doesn't have a full networking stack. So maybe I need to use Wake on LAN or something like that. So these are all the required characteristics. This is what Apple at least thinks to have a TV, here's what you need, is what they're saying. active identifier is an interesting one because it relates to something I'll get into a second, which is the inputs on a TV. Right? Which identifier is active on the TV. And then we have all these optional characteristics, right? Which are things that a TV may be able to provide. Ideally, you could provide them all, or most of them, right? And these are other characteristics, but things that an implementer might not be able to implement themselves, right? Might not be able to pull out of the hat. Or if you're like us and homebrewing something, don't care about turning closed captions on or off. So we'll just be skipping over that characteristic.
That's actually the one I'm most excited about, honestly.
Really?
Because one of my daughters needs closed captions, so we turn it on and off a lot more than most people do.
That's perfect, right? And that's what it's there for. Yeah. And hopefully you would in a perfect world you would find a TV that will have implemented that and not my thing.
Right.
But other stuff that might be unrealistic, especially if, right, the manufacturer is binding HomeKit to an existing API implementation, right? Some kind of service or server that they vend. Maybe they don't have picture mode as an option, right? Maybe they don't have closed captions as an option. A lot of service-oriented APIs for smart TVs are basically just acting as pressing remote buttons, which makes sense, right? That's the primary kind of input you're going to get from a real person. And so HomeKit is optimized around that use case of like, well, I can turn it on and off, right? Another interesting one in here is remote key. These are one of those rare, like, write-only characteristics. Defines a known set of keys, just like 1 through 14 or whatever, that each of those corresponds with a well-known name that is also in this file somewhere of like info, left, right, that kind of stuff, right? Stuff that is already going to be on the TV's remote and that they would want to represent here in HomeKit, optionally. Okay, so continue searching through this file. Television. Let's see. Where are we in the file now? This looks more like a UUID for an accessory tag, right? Instead of the service. I think we just wrapped around. Okay, let's search for active identifier. Okay, here's a template for, again, just by virtue of stumbling on the correct config file, right, that the OS is using for its own purposes. Yeah, we now have an understanding of what this characteristic looks like. Has a description that the OS falls back to, or maybe that Siri will use if you don't give it a name. The identifier, the input source for the TV. We have its format right here, which is a specifically sized integer. Too big for an 8, probably. A localization key, all right, well, this is a beta version of iOS. They may not have figured out the localization thing yet. Yes, here, like Steph mentioned, min value 0. So for all intents and purposes, it's got to be a signed integer, right? Because negative values aren't going to make much sense in this context. Properties 7. Cool, it has 7 properties. No, that's going to be a mix of the set props thing, like we had in Hap.Node.js. So that's going to be like whether it's readable, whether it's writable, and that's bit masking type stuff that'll take a probably. Well, yeah, exactly. Which will probably take some more figuring out, but the simplest way I figured this out was comparing it to other ones in the file, right? The other ones in the file have, correlate to the HAP specification, right? So if I find one in this file that has property 7 and is also in, darn it, wrong screen, and is also in this document, then I know what 7 means now, right? So active identifier, read, write, notify. And probably another flag in there, I think, that's like, this is non-secure. Any user of the house can change this, right? And not have it kill my key, for instance, right? Whereas other characteristics, right, might have secure information about them. Not just anyone can say, ahoy Siri, open the bathroom window. Because then I can climb in the window, you see. Yeah. So properties, okay. So, those are just two concrete examples. We would have to follow through on the rest of this. There was a lot of teasing out, but basically I was able to generate a document, right, that includes, basically takes what all of these things are out of this XML and turns them into definitions that I can use in HAP Node.js, right? So that includes the one that we just, that includes the ones we just mentioned, right? Like active identifier. That includes the services that we talked about, like television. An interesting thing, and again, a good example of how services in the HomeKit definition compose is target control. That is a really generic, perhaps overly generic idea of a service, but it is a thing that has modes. TV has modes, input modes, right? So a target controllable service can be changed into fully different, 100% completely different experiences. You can imagine this was abstracted out of the expectation that this functionality could be useful to another service, to another accessory that's being implemented. So what I would guess is that, and we'll see an example of this in Home in a few minutes, is something that is a target control service knows that it can display a menu in the Home app, right? Or maybe Siri can present you a list of options when you ask to change it. Not specifically related to the TV support. Say, I want to change the mode of the air conditioner. And so they sort of abstracted this idea of what used to be, maybe say in the plain old air conditioner, they would have to hard code heat, cool, auto, off. But I can say, I'm a mode switching thing, and I have heat and off. And here are the names of the things that go in that menu, right? So this could be any menu construct. So we have the television service, which has all those things, has that closed captions characteristic that we were talking about. So all of these different things. The one that I didn't include in this file that was a relationship that I discovered later is that a television speaker is the speaker service. Makes sense, right? Because HomeKit already added support for speakers last year. If you want to have a TV and you want to have volume control on it, then you give the TV a speaker service. This is, again, how fully composable these things are. And then you can shout out to Siri, hey Siri, got it. Ahoy computer, mute my TV. And from last year, the logic that was already implemented, already QA'd, hopefully, to go mute blah, can now apply to an entirely different class of device. Really anything that can be muted, just by building out these different things together. So I was able to take these definitions and then translate them into a file that's already like all the other definitions that go inside HAP Node.js, or something like that, yeah. So we have, just going to show this for a quick second, but everything that's in my notes document is also here in this file. So we can now build out templates using this, just as if Apple had documented them. I can now build out one of those shorter JavaScript files like the button we just built using these template characteristics instead of having to build them all out myself in line. So let me make sure I had nothing else on my slides. Yep, time for a demo of that. So overall, the same overall structure will apply. I'll just return here. There we go. Okay. So similar overall structures. Paste in a bunch of imports at the top. Do the thing where we initialize the storage again, right? Then I'm going to just, whoops. Here at the top of the file, I've included another library, one that I actually wrote myself, for controlling the kind of TV that you're looking at. This is a small node library that interfaces with this big giant TV that's in the room right now. that is just so this happened to be a stroke of luck. I discovered this all this morning. Is this TV has an open port over TCP/IP that you can change the name and password of in the TV settings. I don't know if that's going to get captured on the video feed. Is it? It doesn't matter. Anyway, I can set the name and password for this connection right here in the TV settings.
Yeah, Patrick's gonna be real thrilled.
Yeah, well, it's a pretty TV. It's a nice big TV. Anyway, I will change the password after the end of this recording. Okay. Plus, you have to be on the network in the first place to be able to access this. So there's that. Anyway, okay. So following through with a lot of the original process, we're gonna generate a consistent UUID that I can use across invocations of this file. Right? We're going to export a new accessory. This time, it's named TV, and it has that consistent, yeah. Kevin.
This is a new UID that survives the server. What do you have to survive?
Me killing the process and re-invoking it. Right? So that HomeKit pairing process is exchanging a lot of one-time data, right? iOS or someone in the chain is holding onto the private keys and it's giving me the public keys, right? I have to be able to hold onto those so HomeKit knows how to communicate with my accessory.
Usually
Right.
that's burned into the hardware.
Yeah, exactly. So, right, I will have burned a UUID into the hardware somewhere so that iOS knows how to talk to me again. All right. So just like a longer version of the last exam, we're going to instantiate the television service. Right? So these are just default names for them on the right-hand side. But this follows that television service that I just pulled out of that XML file.
So just so I'm following, your laptop is going to be acting as a television, and it's this Aquos library that's going to be receiving this connection and connecting on HomeKit is then going to forward and talk to the actual physical TV.
Yes, more or less. It's not that my laptop is acting as the TV. HomeKit understands the notion of bridges
Okay.
already, which is why things like Hue, right, why third-party platforms can bridge into HomeKit. It understands the idea that there is a device on my network that is exposing me a whole bunch of accessories that exist elsewhere.
Okay.
So in this case, my computer is serving as like a Philips Hue bridge. It's saying, I'm giving you a bunch of these accessories that I've hooked up, right? So in this case, you would take the Hue bridge that has a HomeKit code on the bottom and add that, and that's an accessory that vends more accessories.
In this thing here, your little process is running on the computer is going to be the one that sends all the commands to the Aqua OS.
That's right. It's going to be going back to the TV, so it's going to be interpreting all of these things that come back from HomeKit and translating them into another format. The funny thing is, I've actually spoken to some engineers inside large companies that are dealing with this, and code almost exactly like this, hopefully not maybe the exact same node implementation, but you never know, is going to be running on the TV to bridge whatever old system that they have, right? Maybe, I know I have a Roku TV at home. That remote is like a Bluetooth thing that speaks the exact same protocol I was using to control the TV. That has its downsides too, because, well, if the remote doesn't support it, you're kind of out of luck, right? But, you know, this kind of code exists to glue together whatever you may have already implemented to control your TV with HomeKit. And this is exactly what people in the real world are doing with it as well.
Gotcha. So I need a bridge I can put next to my TV.
Yeah. Yeah, and we'll talk. We'll actually talk at the end about like how you might use a real world, how you might bridge something in the real world using homebrew code. All right, so I'm going to move it a bit faster of a clip so that we don't stay here all night. This time, I'm taking one of the template characteristics that I included from HomeKit that says, okay, the configured name is user writable, right? If you're in, I'm actually going to pull up my home on this TV real quick, right? If I want to adjust the name inside home right here, right? That is the configured name, the user configured name. This text field, The contrast isn't good, is it?
That's fine.
Okay, the text field that you'll see right here at home, right? That is a user editable thing. Here, and I imagine in a lot of situations, right, the name comes from some UI on the TV, right? So I'll take the configured name here and actually change its properties. Say, this is actually read-only. HomeKit knows how to introspect those properties and go, well, I'll still show the text field for the name, right? Because the name is still a required characteristic, but now the user can't change it. So here, I'm going to bind this now read-only property and not use the storage that's provided for me inside this framework, and I'll bind it. Every time it wants to get, I will then go to the TV and ask it for its name. Any questions about that? Because I'm going to move at a much faster clip now. Okay, great. So we're just going to basically do this for as many APIs as we can discover. If you don't know what an attribute for a required characteristic can be, you can just hard code it. Why not? We're just homebrewing. Sleep discovery mode, it's always discoverable. The TV's on, right? Because of the standby mode thing we already talked about, so it's discoverable. The all-important one, the active characteristic, we bind this to, on get, goes and asks the TV for its current power state. On set, we go and set the power state with the TV. The specific way it's glowing is just right how I wrote the underlying library, or maybe whatever else you're consuming. But all you need to know is that whenever you're done, you call back to HomeKit to tell you that you're done. So if it's taking too long, right, HomeKit needs to know so that it maybe doesn't necessarily let the user chain up a bunch of actions that may conflict with each other, right? If the user gets frustrated and taps on, off, on, off, on, off, we don't want it to turn on, off, on, off, on, off. One side bit here is, right, you'll have to out-convert for whatever insanity that the underlying thing is doing. This actually discovered while I was setting up this process. If I ask the TV for what its power state is, it's 0, 1, or 2. I don't know what 2 means in the sense of on or off. It's really on. So I just say, all right, I guess if it's not 0, it means it's on, and that seems to have played out. But whatever gets it back to, right, HomeKit being a sane, reasonable value. This is going to be an interesting one. So this next one, we're going to take all of the buttons that HomeKit asks for, and I wire them up to remote codes that were defined in the documentation for this TV. Sure, why not? And then that means I can now hook up this optional service for the remote key, which is a write-only value that HomeKit knows whenever the user presses down, it says, all right, the remote key characteristic is now this number. And I look up the translation for it and send it off to the TV. Similar thing for setting the identifier. This one is really easy because the TV already gives hard code numbers to each of its inputs. HDMI 1, HDMI 2, HDMI 3, HDMI 4. 1, 2, 3, 4. So I can really easy just go and say, TV, set your input to number 1. All right, we're done. Let's keep moving. This one's going to be a lot, so I'll take a minute to talk about it. This is actually going to be the Hopper portion of my talk, which we have now axed for time. I'll get to it someday, I promise that. Okay, this is a big screen of things. The display order characteristic is an array of the identifiers based on the order you want them to be in. Otherwise, it's going to alphabetize them, which is really annoying if it's the names of apps. Super annoying. So right here, what I do really quite simply is just hard code an array of identifiers. The format of this array payload is a TLV8. So I have to create a buffer of just these binary values of tag 1, then an integer, then 4, the integer as binary. Then I just tag a few zeros, then, okay, another element, 1, size of an integer, the integer 3 in terms of binary, right? So I build up this array, and I just, for now, you know what? I'm hard coding this as the payload for display order. Ask me or Emil, you have to go. Thank you so much for coming out. I'm sorry I ran over. No. Okay, so we're going to do all that. Now I'm going to move at a much higher, faster clip so we can get done. Okay. This is, again, all the same syntax, again and again. I'm creating another new service. It's the speaker service. I tell it volume control type, right? Whether it's going up or down. When it mutes, I send the mute onto the TV. Also, I misspelled mute. Volume selector. When it sends up, I send up to the TV as if I press the button. When it sends down, I send down to the TV. All right. This is another interesting case. I'm adding its input sources as associated services to the TV. This is what allows me to have many characteristics for an input source. So HDMI 1, that has the HDMI input source type. This also allows it to have user configuration. The user can change the name of HDMI 1 to Apple TV just through the HomeKit UI. And ideally, the TV could reflect that updated state too. Now, we're just bridging it ourselves, so that's probably going to be a read-only value because we can't actually update it on the HomeKit side. Is configured on or off? Maybe something's not plugged into it. If the TV can communicate that information to me, I can express it as configured false. Don't show it in the UI. Then finally, I add it to the TV as this is going to be one of your linked services, one of your linked input sources. I'm just going to do that 3 more times for the rest of the HDMI sources, right? Then finally, I'm going to open the socket to the TV, broadcast it again, just like the last step of the other one. And here's our moment of truth. I'm gonna run it again. Whoops. Nope, that's not it. TV.
2.
Okay.
Is it 2 or just the first one? Oh, sorry.
So we have our TV here. And it has this home, being our home. I'm gonna go back and add an accessory to it. Now we see we have TV. Hey, okay. We're going to go through the same steps that we did before. I actually think my pin code is different on this one. That wasn't it.
It's the same thing. That's what I was thinking. You can't fool us. That's the one I
2,
like.
3, 4, 5, 6. Wait, I'm missing 5. 5, 6, 7. Okay. Added a TV. Okay. So this one has a lot more UI, right? It has that configured name that I was talking about that we've made read-only. You can select the room that it goes in. I'm just going to leave it by the default room. It has the inputs as configurations here. And note, because I marked whether it can be displayed or not as read-only, it has these big honking colorful check marks to the sides of them that are all grayed out. Likewise, I can keep tapping on them, and I can't change the name of them, right? HDMI 4 is going to be HDMI 4 for just, that's the time being, right? Because I can't feed that information back to the TV. Okay, so moment of truth, here we are. We have a TV added to our home. TV support is not public yet. There are no HomeKit TVs on the market, and yet we turned it off. And then I can do turn on the default room TV.
Okay, the default room is on.
And there it's back. And we'll see right here, I can now open it, open the UI for it in Home. I can select the input menu here on the left. It says HDMI 1 is active right now. I can tap here and change it to HDMI 2.
Nice.
And this is all happening right on my laptop. There we go. Hey. Okay. Now we'll return back to it.
Is that
power toggle switch or a scroller? I can't.
Oh no, yeah, that is a big mama power
That's just
switch.
one? Okay.
Yeah.
Holding.
Oh, we were on HDMI 3. That's why. Okay, but that's not all there is to it. Now, this is the hacker community is still trying to figure out how all this works. We're not quite sure if it's just because the beta is broken yet, but TVs also show up as remotes in a control center. So I can select the default room TV, and let's see, I can select the info button, and we get the menu from the TV. And now I can tab around using the up, up, down, down. All being,
So this isn't just the Apple TV remote thing. This is the TV.
this is now TVs, yeah, that I'm talking to TVs. That's right. I can't swipe around like on the Apple TV remote because, well, I only have up, down, left, right. Okay, and I can hit exit, and I go right back out to the thing. What's really neat is I'll change the input one more time.
My kids can no longer lose my remote.
Yeah, I'm so ready to throw away all of my remotes. The last neat one, and this is just systems working together that should have always worked together. I'm on an Apple TV right now. I pull up a remote, not for the Apple TV, but for the HomeKit TV. I tap left, and it goes left. Oh my God. I can now pop into here. We really need some cooler stuff installed on this Apple TV.
Why is the TV's remote just working for the Apple TV?
That's HDMI.
Huh.
Yeah. And I can do this with this TV remote too.
Oh, I see. Oh, because this is just mimicking that remote.
That's right.
It involves the CEC, is that what it's?
Yeah, it's involving the HDMI CEC standard. And I should be able to tap enter, but that's not quite working at the moment. Okay.
So that's not just for turn the TV on or off or switch it to an input, but the CEC also can account for like button control?
Yeah, it's supposed to account also for a lot of stuff related to how audio systems work, turning the volume up and down, that kind of stuff. All right. I don't know why I opened YouTube. Cool.
But Daniel Radcliffe has never been trick or treating.
Okay.
What's that?
All right. So we did that all in just under 200, just over 200 lines of really questionable quality code. We've bound HomeKit to a TV that was never, ever, ever going to have that capability. And I've completely forgotten where my slides are. Okay. So, how do we gold plate this? How do we do this in the real world? So, no one can see that. There we go. Okay. How do we gold plate this? How would you actually do this in the real world? So there is this hap.node.js library that we built things out in. There is let's call it a framework too, that's built on top of that called Homebridge, which is intended more as a daemon type process, right? That you build out these plugins and it uses a configuration to drive the same stuff that we just wrote. So someone, I don't think this one is actually written, but someone would say, write the Aquos TV plugin, and you would cobble together several of those plugins, right? Maybe you would bridge in your old air conditioning unit, that kinds of things, and run it together as one Homebridge server. So that can be on a home server, on a Mac Mini, on a desktop, something that's always on and able to facilitate those stuff. My personal favorite is hosting it on a Raspberry Pi. Yes, it runs. It's perfectly fast. There are no issues with it. I love this photo of it because it's got the quarter in it. These things are so hecking small. I actually have this exact model, the Pi 0W, with my Homebridge setup on it, and it's taped to the back of my TV. You would never know it was there. And that's how we bridge these two things together. Okay, so I promise I'm wrapping up. We're finally there. We're getting there. So what have we learned about HomeKit? It's not just for shiny widgets like light bulbs that change pretty colors. It's actually a system for just really generally things talking to each other within a house concept, right? We just did it in an office here. So things talking to each other within a building. It's not just jokey Internet of Things things. This is actually a technology that's meant to stick around. It's made to make the hard stuff about having these things talk to each other, whether it's over Bluetooth or Wi-Fi, secure or not secure, it's there to make it resilient, right? And like the example I gave earlier, it's not just the data types that Apple defines. You can define your own data types, build your own apps. right? That then communicate this custom data while still holding on to all the benefits of HomeKit, right? Security, all that stuff. Backing all the way out, way back to the way how we started at the beginning of the talk, some 14 hours ago at this point, is what is this really crazy obsession that I have with digging into things? What does that help us? We learned how the system works, or at least appreciated that it is working for us, and it is removing a lot of the things that screw up about, for instance, in HomeKit, how Internet of Things devices can screw up your network, screw up your life if someone hacks into it. It's removing all of that stuff. And knowing that it does all of that helps you make informed choices in your day-to-day. Knowing how to do this stuff, following those steps of searching, then finding neat things, then pulling them apart and finding out the why of something is a way to increase your debugging skills tenfold. If you even know how to look at one line of assembly, you will be able to fix almost any issue, I promise you. And you can do cool things like annoy people for several hours at a time with talks. So that's me. You can contact me via email if you have any questions about this. Otherwise, we're going to wrap it up because we all want to go home. Any questions? Okay, yes. I imagined that would be the case. Yes, thank you. Okay, yeah, hey.
That was very cool.
And if you don't know any lines of assembly, then come back for Zach's next talk where
I'll be doing this. Yes, I'll be doing this for real.
The good news is you already prepared for it, so.
That's right.
This was originally supposed to be that, and then I couldn't find, this was originally supposed to be like a reverse engineering talk, but I couldn't find a good enough example to hang it off of, so I decided to talk about this instead.